If you want to become an AI engineer in 2026 and you're feeling completely overwhelmed by the sheer number of tools, frameworks, and platforms out there, this video is going to cut through all of that noise for you. I'm going to walk you through the exact categories of the tool that you need to know, the specific tools within each category, and what they actually do, and most importantly, why each piece fits into the bigger picture. Because here's the thing, most people get stuck trying to learn everything and they end up learning nothing deeply enough to actually get hired or build something real. I get it. When you look at the AI engineering landscape right now, it feels like there is a new tool dropping every single week. We have LangChain, LangGraph, vLLM, Pinecone, V8, OpenTelemetry. The list goes on and on. And if you're sitting there and thinking, where do I even get started? You're not alone. That feeling is completely valid. But here is what I want you to understand. You do not need to learn everything. You need to learn the right things in the right order and understand how do they connect with each other. That's exactly what I'm going to do today. If you don't know me, I'm Aishwarya Srinivasan. I have been in the machine learning and AI space for over 10 years now. I did my master's in data science from Columbia University, and I've had the chance to work at places like Microsoft, Google, and IBM. I'm leading AI developer relations at Fireworks AI, which is one of the top AI infrastructure startups right now. So I'm not just telling you what sounds good in theory, I'm telling you what actually matters when you're building and deploying AI systems in real world. So let's start with, what does AI engineer really mean in 2026? Let me start by setting the context, because the term AI engineer gets thrown around a lot and it means different things to different people. In 2026, when companies are hiring AI engineers, they're looking for somebody who can design, deploy, evaluate, and operate AI systems in production. And most of the times, these systems involve agents, RAG pipelines, and multimodal inference. This isn't about training models from scratch anymore. That's more like ML research or ML ops domain. AI engineering is about taking powerful models that already exist and building applications on top of them that actually work reliably in the real world. So here is the mental model I want you to have. Your tool stack should map to the actual life cycle of building AI applications. And that life cycle looks something like this. You build, then you orchestrate, then you retrieve, run, evaluate, observe, and iterate. So as I go through each category, I want you to think about where it sits and why it matters. Alright, let's start with the foundation. This is where you build and orchestrate your AI applications. The first tool most people learn is LangChain, and honestly, it is still a great starting point. It has broad integrations, pre-built patterns, and it lets you get up and running fast. You want to understand core abstractions, things like messages, prompt templates, runnables, and output parsers. You'll also want to learn how it handles tool calling, structured outputs, and retrieval integrations. But here is where it gets interesting. When you need more control, when you need durable, stateful agent workflows, that's when you move to LangGraph. Think of it like an evolution of basic agent patterns into something more production ready. You're dealing with graph execution, checkpointing, human in the loop control points, and separating your planner from your executor from your validator. This is where things start to feel like real software engineering. And then there's OpenAI Agent SDK. Even if you're not building exclusively on OpenAI, this SDK is worth studying because it is a master class in clean agent architecture. Tools, guardrails, handoffs, typed outputs. It shows you what a disciplined agent engineering looks like. The key takeaway here is, start with LangChain to learn the basics, then graduate to LangGraph when you need durability and control, and study OpenAI Agent SDK to internalize good architectural patterns. Now, category 2 is connectivity and enterprise integration. This one is huge, and honestly, it is something a lot of beginners completely overlook. MCP standardizes how LLM applications connect to tools and data sources. It gives you clear boundaries around authentication, permission, and capability exposure. Now, trust me on this. When you're working in any enterprise environment, understanding MCP concepts like least privileged tool exposure and auditing is going to set you apart from engineers who only know how to call APIs in a sandbox. Then, in category 3, we have models and inference runtimes. In 2026, saying I only call APIs is not enough if you want to be a serious AI engineer. You need to understand both managed platforms and self hosted inference engines. On the managed side, I'm obviously biased here, but Fireworks AI is a production platform I would highly recommend for running and tuning open source models. What you want to learn here is the trade offs. latency versus cost versus quality versus context length. You should understand concurrency, streaming, batching behavior, and how to use embeddings and re-rankers as endpoints. If you're fine-tuning, you need to learn versioning discipline. On the self-hosting side, we have vLLM. vLLM is the go-to open source LLM serving engine. So you need to learn how throughput and tail latency work, understand KV caching constraints and memory behaviors, and get comfortable with quantization trade-offs. For high performance inference, especially for non-LLM models like embeddings, re-rankers, or computer vision models, NVIDIA Triton Inference Server is core infrastructure. Dynamic batching, concurrency tuning, model repositories, and ensembles for pipeline serving. These are the concepts that you need to learn. And finally, we have BentoML. It is also a great platform for packaging and deployment discipline. Reproducibility packaging, API schema design, container native serving. This is where your ML engineering fundamentals meet the production deployment. So the bottom line here is you need to be comfortable on both the sides, calling APIs for rapid development and understanding the infrastructure for when you need to self-host or optimize. Then category 4 is retrieval and vector databases for RAG. RAG is everywhere in 2026. If you're building AI application, you're probably building some form of retrieval augmented generation, which means that you need to know vector databases. So here is my recommendation. Learn one vectors inside your database option and at least one dedicated vector database. For the first category, PG vector with Postgres is incredibly pragmatic. Fewer moving parts, and if you're already using Postgres, it's a natural fit. Learn the index and distance metric choices, hybrid retrieval patterns, and chunking failure modes. For dedicated vector databases, Viviet is excellent. It is open source, has built-in hybrid search, and it is popular in RAG stacks. Pinecone is a managed option that's designed for production at scale. Either way, you need to understand schema design, ingestion patterns, index configuration trade-offs, and multi-tenant patterns. Here is the thing most people get wrong with RAG. They focus entirely on the retrieval side and forget about the context assembly problem. Understanding how to chunk documents properly, how to avoid retrieval failure modes, and how to configure hybrid search is what separates a working RAG system from the one that hallucinates constantly. Now in category 5, we have evaluation toolkits. Let me be real with you. This is the category that separates hobbyists from professionals. In 2026, evaluation is not a research luxury. It is CI or continuous integration for AI behavior. If you're not evaluating your AI systems rigorously, you're flying blind. LangSmith is commonly used along with LangChain, but can also work with framework agnostic ways. So learn how to build datasets from real traces, run offline versus online eval workflows, and use different evaluator types, whether it's rule-based, LLM as a judge, or human review. Now, RAGAS is focused specifically on RAG quality. Faithfulness, relevance, groundedness, these are the metrics that you need to track. It is excellent for regression testing across retrieval and prompt changes. Then TrueLens uses a feedback function style that is useful for component level scoring. You can score retrieval, tool use, and final answers separately, which gives you much more granular insight. And MLflow for GenAI evaluation treats prompt runs and evaluations like tracked ML artifacts. Versioning prompts, comparing runs quantitatively, storing eval artifacts per release. This is mature ML discipline applied to generative AI. Here is what I want you to take away. Evaluation is not something you add at the end. It is something that you build into your workflow from day one. Then category 6 is observability, tracing, and monitoring. The last category, and honestly one of the most important for production system. You should learn one foundational standard plus 1 to 2 LLM native observability platforms. OpenTelemetry is your foundation, which is vendor neutral traces, metrics, and logs. Context propagation, latency percentiles, error budgets, correlation of model calls with downstream failures. This is standard infrastructure observability that applies to any system. Then Open Inference adds convention specific to LLM tracing. Standard span attributes for prompts, retrieval, tool calls, and model invocations. This is essential for debugging hallucinations and tool misuse. For LLM native platforms, LangSmith does observability alongside its evaluation features. Now, Galileo is positioned around reliability, guardrails, and enterprise workflows. Then Phoenix and Weave are useful as LLM application debugging layer options. What you need to learn across all of these is trace level debugging, comparing releases on latency, cost, and quality, and linking evaluation regressions back to concrete traces. When something goes wrong in production, and trust me, it will, you need to be able to trace exactly what happened and why. Alright, let's bring it all together. If you're aiming to be an AI engineer in 2026, here is your toolkit across the lifestyle. LangChain, LangGraph, and OpenAI Agent SDK for building and orchestration, MCP for tool connectivity, Fireworks AI, vLLM, Triton, and BentoML for inference, PG Vector, VV8 or Pinecone for retrieval, Langsmith, Ragas, TrueLens, and MLflow for evaluation, and OpenTelemetry, Open Inference, and platforms like Galileo or Phoenix for observability. I've linked all of these tools and resources in the description below so you can dive deeper into any of them. Now, if you found this video helpful, do me a favor, hit that subscribe button and turn on the bell icon so you don't miss my future videos. I post regularly about AI ML career tips, free resources to help you level up, educational explainers on concepts that actually matter, and I also share my journey as an immigrant building a career as an AI leader here in the US. Now, I want to hear back from you. So drop a comment and let me know, where are you in the AI engineering journey? Are you just getting started, or are you already building production systems and looking to fill gaps? And what are the topics you would like me to cover in the next videos? I read every single comment, and your questions genuinely help me to shape what I create.